Welcome to today's webinar on mainframe data, cloud ready, no code. And we're going to focus on PropelZ today and just kind of the differentiators on how easy it is to implement without scripts, APIs, in a completely no code fashion. And so I'm Dustin Froyum. I am one of the co-founders of VirtualZ. And today I have Vince Ray, our co-founder and chief technology officer, co-presenting with me. Good morning, Vince.
Oh, morning, Dusty. Looks like an interesting topic today. Looking forward to the discussion.
I think it'll be fun. I know we've been talking a lot about PropelZ, and it's always a little different, so I'm looking forward to it. So let's just talk a little bit about where we're coming from and legacy of ETL and some of those challenges. So I think if we've been around for a long time in this mainframe space. Sharing of mainframe data can be really important since that's most of today's still your business critical data. A lot of it resides on the mainframe. And those processes that were developed over time were out of necessity, right? We had lots of homegrown ETL processes, custom extracts, did all your data transformation on your own. But those can come with a lot of expense and effort to maintain those over time, as well as taking up a lot of mainframe processing resources to do those ETL activities. So today we have better ways of doing that, and there's some commercial products on the market as well that kind of focus in this space, but many of them are still very resource intensive. You have to do a lot of coding, scripting, implementation work to maintain those. And so we're going to talk a little bit about the differentiator with our approach and making it truly no code, be up and running in a couple hours and sharing that data as you see fit. So Vince, let's talk a little bit about the PropelZ architecture to start and just kind of what you've created here and why it's a little bit different.
Yeah, so, well, let's start with the basics. PropelZ is mainframe software. It installs on your ZOS system. It is a zIIP eligible workload, so it runs on a zIIP processor or processors if you happen to have many configured. And of course, that's important because it means that the processing capacity we use isn't going to drive up the cost of your whatever software stack you have that might be licensed on a subcapacity basis. So zip eligible, very efficient, all of that. But going a little bit deeper, the way to think of PropelZ is it's really three simple parts. The first part is all about data access. In other words, where do you want to get your data from? Is it a VSAM file on the mainframe? Is it a sequential file? Is it database on the mainframe? Wherever that data is, you can ingest it into PropelZ in that initial stage. And by the way, just to be clear, it doesn't actually have to be data. One of the demos that we've done shows using things like ZOS console messages as input that we can push to various management tools through PropelZ. So really, anything that you might have access to on the mainframe is suitable for input. Once we ingest the data, the middle part of PropelZ is all about understanding that data and transforming it. One of the things that makes mainframes challenging to integrate into things like whether it's cloud or AI apps or whatever it is, it's that mainframe data formats are a little unusual and non-standard. We see things like whether it's mainframe use of packed decimal or mainframe floating points or timestamps. These are all kind of specific mainframe data formats, and PropelZ understands all of them. So we can take a look at, for instance, a VSAM record that has all of these complicated mainframe data types in it, and we can transform that into something that's much more understandable. Could be as simple as rows and columns. If you're looking to get that data into, let's say a relational database, yes, that's pretty straightforward. If you're looking to do something more than that, then it might be converting that data into a JSON object or an XML object or a CSV format where you can do other things with it. So, one of the key points about PropelZ is that, of course, there's no magic in the universe to understand the data at a field by field level. We need a little bit of metadata that describes your information. One of the big features of PropelZ is that although there's some different ways of doing that, the simplest thing to do is just point us to something like a COBOL copybook, which you likely already have, that describes those records. And we can ingest that, process that. Now we understand your data at a field by field basis. It's not just one big blob of mainframe data. It's, here's the name, here's the address, here's, whatever other fields might be in that record. So that's the processing in kind of the middle stage. And then finally, once we've kind of interpreted the data, the, the, the final stage of PropelZ is putting that data somewhere, wherever you need it to be. It could be in a database of some sort. It could be driving an API with that data. It could be pushing it into really anywhere that you might need it. And again, one of the things that's unique about PropelZ is we're doing what I'm describing natively on z/OS. So, some of the competing technologies we've seen, a lot of folks will take mainframe data, transfer it to, some sort of middle tier, which might be Linux or Windows or some other platform. And then you've got this kind of separate process that does some of what I'm describing. Take the data apart and push it to a destination. And in my opinion, that makes it needlessly complicated, error prone, difficult to diagnose when something doesn't work properly. In our case, everything stays on the mainframe. It's easily integrated with whatever mainframe processes you have. It's easy to manage, it's easy to secure. All of that just happens like any other mainframe application would happen. So, very, very mainframe centric there in terms of the processing, but the data could be wherever you want it to be, whatever platforms, whatever networks, wherever you need it to be. So, Dusty, what did I forget to mention that I should have drilled into?
No, I don't think that's a good overview, Vince, but I do want to ask a couple questions that kind of the advantages of the architecture. So one of the things that I know is in particular, right, is being able to run Propels easily in an online window, not just in a batch cycle, but also the incremental update capability because of this architecture and the direct access. Can you talk a little bit about that part?
Yeah, so PropelZ can run a lot of different ways on your mainframe. In one example, you might have production workloads that are creating various files that you want to synchronize with the cloud or push into an AI application when they're updated, whatever your needs are there. And that's really easy to do. You could run PropelZ with nothing more than standard mainframe JCL. It's easy to integrate with, you might have a job scheduling product of some sort. Very easy to integrate with that. And in a lot of cases, you might just have an existing, let's say a batch job that creates a file that needs to be synchronized to other platforms. You just add a step into that kind of JCL, and PropelZ does its thing. every time that job runs. So that's kind of, I think of that as kind of the production use cases. You're running PropelZ on an ongoing basis. It's scheduled, it's probably monitored and controlled and so forth. Dusty, as you said, there's also a set of use cases around using PropelZ interactively. I can also set up PropelZ so that really any user with access to whatever data he wants can just type in a PropelZ command, and now it does its thing, and your data is wherever you need it to be. And again, one of the cool things about PropelZ is everything is defined by nothing more than configuration data or command line options, all of that stuff. So Dusty, you and I could run PropelZ at the same time against the same data. Maybe mine goes to, I don't know, an Oracle database, and yours goes to, Azure or Snowflake, or into, a completely different place in a completely different format. So yeah, that's an important thing here. It's both an on-demand interactive tool and a kind of production-ready tool that can be integrated with your existing workloads. Now, one of the other things that you mentioned is also the incremental processing. A lot of sites have large files that they don't want to just do a one-time move to the cloud. They want to keep the cloud loosely synchronized with that data. So, we can work in that mode too. We can, you can do things like monitor a given file on, whatever basis you like, every 30 seconds or every hour, whatever makes sense to you. And we're able to look at that file, compare it to what's in the target, and automatically synchronize the two. So if I add a bunch of new records into a VSAM file, those added records will end up in the cloud. If I change some records, the changed records will end up there. And in fact, even if I delete some records, the deleted records will disappear from the target. So, this gives you a way of, if you had, let's say you had an enormous file, terabytes long, you don't need to think about synchronizing it, let's say once a day, or, whatever you might need. You can just run PropelZ in this incremental mode, and we'll just capture the changes since the last time we ran. And that gives you a target very, very quickly without having to think about moving all of that data potentially across a slow network or to a target that might be slow for whatever reason. So, incremental processing works on anything we support. So, VSAM files, and honestly, with things like VSAM, there are usually lots of different ways we can get to this solution. But usually it's going to be way more efficient than what some of the competing products do around change data capture. The problem with change data capture is typically it's it's a synchronous process. In other words, I have a mainframe application, it writes to a particular file. The CDC technology needs to capture that, record it in some kind of log file someplace. And, depending on your needs, it might actually have to communicate that change all the way out to the target before that initial application write could be considered complete. And what that means is that there's performance issues there, there's stability issues there. What we do is, in contrast to that, is completely asynchronous. If there's, let's say a network outage, doesn't particularly affect us. Certainly your target is going to be out of sync while the network is down. But as soon as the network comes back up, everything will be synchronized again. No impact to running applications on the mainframe, really, or in the cloud, other than this fact that your data may be out of sync while while that change goes on, while the network comes back online. So Yeah, and we've heard this pretty
Hmm.
often from customers. I mean, Dusty, you and I visited one that told us they spent 2 years trying to get the CDC approach working. And by the time they thought about upgrading their VSAM files and defining log streams for them to write changes to, and putting all of these other pieces we're talking about in place, I think they finally just gave up on it
Yeah.
because it was just too big an operational problem for them. PropelZ running asynchronously, bringing that file on the target into sync every few minutes was more than adequate for their needs. And it was something that just worked on the current configuration. No need for logging or log streams or upgrading the type of VSAM that you're doing, or none of that is required for our incremental processing here. So, yeah, I mean, certainly we'd be happy to have a deep dive onto what your requirements are, and we can talk about what the limits of that might be. But from most of the use cases we hear about, the incremental approach that we take tends to be much more straightforward, much more efficient.
Yeah, that poor customer, I mean, they spent millions and millions of dollars, literally 2 years, and they got nothing out of it. And so yeah, they were and they really didn't need a completely synchronous approach, right? As you said, Vince, they just needed it updated about every hour. And to feed in their AI BI platforms, just make sure they had some current data, so that they just had over engineered that. And we've heard that story repeatedly, right, in some of these instances. Now there are cases where you want to have full synchronous read write capability, and we have a solution for that where we'll just allude to that a little bit today. That still simplifies that process pretty drastically. But
Yep.
yeah, just that customer, I mean, man, they were just and that's why they're looking at PropelZ to kind of simplify their world and their needs quite a bit. So Vince, you alluded to this a little bit, but um, you know, in the architecture, right, got the input, the kind of the PropelZ, we'll call it processing, and then the output targets. So Vince, is there any limits to what we can do on the mainframe, let's say source side to start?
Yeah, not really. I mean, certainly the most common things we deal with are files. And that could be, most of the things that you've listed here. They could be, complex VSAM files at one extreme. They could be kind of boring, let's say tape data sets at the other extreme. That's everybody has these things, and they're always problematic to move around. So, those tend to be the highest value use cases. But the other thing that PropelZ can do with the input is you can basically pipe anything you want into it. So, for instance, you could run IBM's, let's say their DB2 batch query capability, which executes a query against a DB2 system and returns a bunch of rows. You could take those rows and pipe them into PropelZ, and that's perfectly fine for data as well. We do include a JDBC input capability. So, I mean, we're talking about it as the sources are mainframe sources, but technically, the source could be, let's say, an Oracle database running on a Linux server in the cloud. We can process those records also. The advantage to that type of processing is, in that case, you don't even need the type of metadata that I described. You don't need, um, COBOL copybooks that describe your data or any of that stuff. The JDBC query you do produces metadata, and we can use that to understand the structure of the records that came through. So that's probably about as simple as it gets when the source data is sitting in a database of some sort. You don't have to know really anything other than here's the name of the table or here's a query that I want to issue. to materialize some data, and we'll take it from there. We can figure out the rest based on that. So yeah, very open-ended on on that end of it. And by the way, that means, and I kind of alluded to this before, we've got examples where we're doing things like taking real-time SMF records as they're produced in the zOS. So there's not a file even involved in that case. It's basically an API approach. Process the record as it comes, as it's generated by the system, and then that can go into PropelZ, and that data can be pushed wherever you'd like it to be pushed. So, lots and lots of possibilities there. You could envision, I don't know, run a Kix transaction and then take the output of that transaction and propel it to a target environment of your choice. So yeah, very, if you can imagine it, we can probably figure out a way to get it into PropelZ given the architecture that we have.
Yeah, and the one that has come up pretty frequently for us, and we'd love to hear from you if this is a use case for you, is IBM iOS, right? So AS400, iOS, iSeries. So yeah, we'd love to kind of hear if that's a particular use case. So Vince, a little bit deeper on the target side and that architecture and where we can go from targets. And again, I think this is a big differentiator for us and why we're a little different.
Yeah, and the most common, just like files are the sweet spot and the most common thing we hear as inputs. On the output side, the most common things we hear are basically variations of databases, whether that's, something like, the ones you show here, Vertex, but really it could be just about any type of database. It could be a relational database, could be, a NoSQL database, it could be an AI platform that has, a JDBC layer over it. There are probably 100 of those out there that we support out of the box. Now, when you license PropelZ, we provide 5 of those that I'll call certified. In other words, they're ready to use, no configuration, nothing more than that. Those 5 are Microsoft SQL Server, Oracle database of different types, Postgres, MySQL, and Snowflake is the 5th one. We're happy to do anything beyond that, or you can do it. It's an open architecture. Really, all that's needed is a little bit of configuration data, which is usually about choosing the right data types. I got a mainframe floating point number. What does that need to be represented as in the target database? And then you supply amounts to a driver. So, typically that's going to be a JDBC driver that can communicate to the target. As I said, we can do that work. It's pretty trivial amount of work, or you're welcome to do it yourself. If you let us do it, the advantage is that we license. I'm going to call it the industry's highest performance JDBC architecture. These are not open source JDBC drivers. These are, best of breed JDBC drivers. They tend to be dramatically faster than many of the alternatives. So, if we do that work for you, that's what you would get. If but again, there's no reason you have to do it that way. You're welcome to supply your own JDBC drivers and configuration data, and you can connect to anything. And as I mentioned before, and sorry, I'm going on a while about this, but it doesn't have to be JDBC. It actually can be, just as I mentioned, you could pipe just about any type of data into PropelZ. You can do the same thing on the output side. We have an example where we take zOS console message traffic, and instead of a JDBC connection to a database, we pipe that into the Splunk product using Splunk's APIs. So, it's pretty much the sky is the limit. And again, this is the type of thing we would be more than happy to consult with you guys on, and either make recommendations or, do some of that work if anything custom needs to happen there, or, really, just act as enablers for, whatever you need to make happen.
All right, thanks, Vince. I'm going to talk a little bit, and you've alluded to some of them, some of the demos and use cases that we have available. So one of the demos we have is taking a very complex, large VSAM file, moving it to a MySQL database, and then presenting that in Tableau. So the demo, if you go to our website, under each product has demos. You can see this in action, and the real elapsed time, just to kind of talk to the simplicity and the ease of implementation of PropelZ, is under an hour. So from install, taking that mainframe file, moving it to MySQL, and presenting it in Tableau. So it's a pretty powerful demonstration. And of course, it doesn't have to be Tableau. It can be any AI, BI platform, feed it directly into that platform, depending on what the staging database is, or if they have a direct JDBC driver like Snowflake or Databricks. So that's a really, really cool thing to be able to do. And Vince, we've talked to customers, right? They're just flabbergasted by that because of how quickly we can ingest that data. I know we were talking to one customer, they have to wait 4 to 6 weeks for any change in their VSAM file, right, to go through the analysis and the setup and the configuration. And they just couldn't believe we had automated that. And so you can see that in the demonstration. One of the really cool use cases that's come out is using PropelZ really as a storage solution. And so we have several instances where just want to take legacy tape file data, get it off the physical tape or even off VTL, or just create another cloud backup to that data versus having to expand their on-prem storage by rolling in new VTL systems, and using PropelZ to do that. Again, could be a secondary or even tertiary copy. And it go to the cloud. It doesn't have to be in the cloud, right? That could even be in a co-located database on distributed servers. And so that's a really, really cool implementation of PropelZ, and huge money savings over some of the legacy approaches to that. All right. Oh, I think I got my slides out of order here, maybe. Sorry about that. Vince, you talked a little bit about the Splunk demo. That Splunk demo is also available on our website, and you can see that in action through that integration. That's a really interesting variant of PropelZ as well. So I wanted to talk a little bit about why, just the pricing model for PropelZ as well. So PropelZ is $50,000 per year, unlimited data. So all these functions, all these capabilities we're talking about is $50,000 per enterprise. And that comes with the drivers that Vince mentioned, those 5, and we'll be glad to test and configure additional drivers for a small uplift and certify those and ship those as well. Typically that's 5 to 10 to 15,000, depending on what that driver is. And if there's some of these JDBC drivers are kind of interesting. They have some interesting functional gaps, right, Vince, that we've discovered over some of these implementations. So again, $50,000 can do any one of these use cases. There's no limit to that enterprise, so there's no hidden costs or anything to that. And that's a pretty distinguishing feature from what's in the market today, that costs hundreds of thousands, if not millions of dollars for, and then requires a lot more processing capability and maintenance as well. I'll just mention, so I alluded to Lozen. Lozen is the real-time read-write. Again, would get rid of your change data capture. So the mainframe remains your system of record, right? Completely synchronous to your cloud and distributed apps that are interacting through Lozen. So that's a really cool one. And then Zach is primarily a storage product. So really for the first time, we've brought virtual disk. There are some virtual tape solutions, but a very, very different architecture and approach than we take. But you can run Zach at cloud or SAN storage as just as if it's DASD, so virtual disk, or you can run it in tape, and you can do that in parallel as well. So another it's a slightly different backup use case, but you can use Zach for those backup use cases that we talked about with PropelZ as well. Okay, I'm going to pause and see if there's any questions in the chat. And I had one other question. So Vince, you alluded to this as well, but is you beyond the zIIP savings, the performance potential and savings is pretty substantial as well. Can you talk a little bit about that part?
Yeah, so I mean, absolutely, the zIIP isn't, I don't necessarily think about that as performance. I think about that as cost containment.
Mhm.
Those are basically, the way I like to say it is the MIPS you consume there don't spin the software meter. So it's not the kind of thing that you bring a new workload to your mainframe and suddenly everything on the mainframe gets more expensive because you're using more mainframe capacity. In this case, that's not true. In this case, as long as you've got a zip engine, then our code runs there, and you don't have any of those issues. But beyond that, I mean, there's several other important performance things here. I mentioned one of them before. The point is that we are not just running on the mainframe, but we're doing everything we can from the mainframe. So we'll directly connect to the target. It's not like there are multiple hops. It's not like your data goes from your mainframe to some middle tier platform and then to the target. It's direct to the target. Number two, we use protocols that are optimized for remote database access. I mentioned JDBC. That's a great example. The different database vendors have spent, I don't know, 20 years figuring out how to get optimum performance in a network connection. This is really different than some of the competing products that use like HTTP transactions, things that were designed for the web browser, not for moving big chunks of data around the network. Beyond that, we also have full support for transaction management, for bulk inserts, and on and on and on that way. So give you an idea how this works. A lot of databases by default, if you insert a row, there's a commit that's being done. In other words, you send the row, the database does its thing, and it sends you back a response. And of course, that can be really slow. With PropelZ, we generally would recommend running in bulk insert mode. What that means is you might do literally tens of thousands of inserts as a single transaction. So you might send tens of thousands of rows to the target and then do a single commit that deals with all of them in one shot rather than having to do that record by record by record. In our tests, that's worth at least 500% improvement in performance, depending on the database and how fast your network is and all of that. So, a lot of that, of course, can also be tuned for your specific needs. I mean, most of the sites we're talking about are going to be mainframe customers. They're going to have, experience with accessing, whatever their preferred remote databases are. And, I like to think that, most of the people in that environment have a pretty good sense of what the optimum solutions are. So we allow you to, tune for that, to really take advantage and use your own expertise and experience with, you in your specific environment to get the maximum performance out of things. To put it on the map, and again, I often mention the statistics we see, but the footnote to that is that understand that we're running in a teeny environment. Our mainframe is an IBM zPDT development environment. It's basically ZOS running on a big PC, if you will. So, and by no means is this serious mainframe configuration. And then the targets we use are things like databases running in, let's say the Amazon free tier or the smallest possible Azure configuration. So, these are teeny targets. And the network we run is basically consumer grade gigabit Ethernet, nothing faster than that. And yet, with all of those restrictions, we can take, the data that Dusty mentioned before. This is, a large VSAM file that has information about all of the world's airports. It's roughly 80,000 rows of information. Each record is, a couple of dozen fields. Each record is about 1K in length. It's VSAM KSDS, and in that really primitive environment that I'm talking about, we get somewhere around 6,000 rows per second when we run PropelZ and push this to a Postgres database. I would imagine somebody with a really big mainframe and a serious mainframe connection, over network to whatever target, you should have no trouble getting at least 10 times what we get in terms of throughput that way. And again, it's all tunable, it's all configurable, just simple options that you can configure into the system, and you'll get the the behavior that's appropriate for your environment. So yeah, I mean, we think that we've heard some pretty severe performance requirements, and at least so far, none of them really scare us too much. We know that we've talked through enough of these scenarios with enough customers now that we generally don't look at it with uh-oh, that'll never work because of performance or that kind of thing. So we think that that's a big plus for us that way. Plus, one other thing I'll just throw in when we're talking about performance. I mean, Dusty mentioned use cases like moving a virtual tape library's contents to a cloud-based data, whatever it is, database or whatever environment you want. The problem there is that it's not just one file that you're moving. It might be literally millions of files that need to be moved, right? That tape library might have a gazillion tape volumes in it, and each tape volume might have multiple data sets on it. So there, the issue isn't so much just raw throughput, it's also scale in terms of parallelism. How many of these can you do in parallel? And we have a solution for that too. We have, it's a small component of the overall package, but it allows us to run multiple instances of PropelZ truly in parallel. So, let's say you had, I don't know, 4 or 5 zIIP engines. You were okay with us using all of that capacity because you have this massive data migration project. We might run, let's say 100 of these tasks in parallel, and really take advantage of what your environment could do. So there are those kind of things too. It's not, sometimes performance isn't just the bit level of how do I make it run fast over a network. Sometimes it's the operational performance of how do I scale this up to handle massive number of files, or whatever those details might be. And we do both, certainly.
All right, thanks, Vince. All right, we're a little over time, so I'm going to wrap us up. We have a ton of resources available. We have blogs on just thought leadership type stuff, and modernization in place, lots of detail, other Q&A type things about each of one of our products and different use cases. I mentioned a couple of the demos on demand, but we have demos on each of the products that you can take a look at. And then, we have a lot of events going on. We're in a pretty regular cadence on different webinar topics. We also have a podcast called Skyward Data. These are all put on the podcast as well, so you can listen to these on Apple Podcasts or anywhere that podcasts are available. They're published there. So those are available, and we have some really great guests too as well on those podcasts. So check that out. And then if you'd like to discuss any other particular use cases or needs, or just have feedback for us, you can reach out to us at hello@virtualzcomputing.com, or if there's a POC, we offer all no-cost POCs. All of our products install very quickly, and you can run those POCs. Most of our POCs last about a week. PropelZ usually a couple days at the most, depending on the configuration. So just reach out to us. They're easy to implement and get started and validate for you as the customer. So, all right, thanks, Vince, so much for joining us, and we'll catch you on the next one.